Kali Linux can put hundreds of security tools on your screen, but tools do not make you an ethical hacker. If you cannot explain where you are, which user you are, what a command will change, or who can read a file, the terminal becomes a liability. Let's fix that foundation first. By the end, you will understand the terminal, Linux paths, common file commands, pipes and redirection, permissions, processes, basic network inspection, package updates, and a safe investigation workflow. We will not run attack tools. Kali Linux is an open-source, Debian-based distribution built for penetration testing, security research, forensics, and related specialist work. It packages many tools, but it is still Linux underneath: users, files, processes, permissions, packages, and networks. Kali's developers say it is not recommended as a general-purpose desktop or as the first distribution for learning Linux from scratch. Build fundamentals first, then use Kali for authorized security work. For a beginner, an official Kali virtual machine is usually the safest starting point. It separates the guest from your main operating system and lets you revert snapshots. Use synthetic data and a lab network, not real targets. Practice only on systems you own, systems you are explicitly authorized in writing to assess, or purpose-built labs. Finding a system, knowing a command, or installing Kali does not grant permission to test it. The terminal is the interface that displays text and accepts input. The shell, often bash or Z shell, parses your command, expands variables and wildcards, starts programs, connects input and output, and reports an exit result. A prompt often shows the current user, computer name, and working directory. A $sign commonly indicates a regular user, a hash often indicates a root shell. Prompt styles vary, so confirm with commands rather than guessing. Start with 3 harmless checks. Whoami prints the effective username. PWD prints the current working directory. ID shows user and group identifiers. These answer who the process is and which access rules may apply. Use man followed by a command for its manual page. Many programs support --help. Use type to learn whether a name is a shell built-in, alias, function, or external program. Documentation should come before improvisation. In ls-l/var/log, ls is the command, -l is an option, and /var/log is the target. Quoting matters when an argument contains spaces or special characters. Read the whole line before pressing enter. Think of the terminal as a control room. The prompt is your instrument panel, the command is a control message, and output is system feedback. A skilled operator checks the panel, sends one precise instruction, reads the response, then decides what comes next. Linux paths form a tree rooted at /. User files commonly live under /home. System configuration often lives under /etc. Variable data such as logs may live under /var. Temporary files commonly use /tmp. A tilde represents the current user's home directory in many shells. That makes ~/lab a convenient path. It is not the same as /home for every account, so let the shell expand it. An absolute path starts at / and identifies a location from the Filesystem root. A relative path starts from the current working directory. Relative paths are shorter. Absolute paths reduce ambiguity. Use PWD when context is unclear. A single dot means the current directory. 2 dots mean its parent. CD ... moves up 1 level. These are path components, not vague gestures, and they can appear inside longer relative paths. ls lists directory entries. ls-l adds ownership, permissions, size, and timestamps. ls-la also includes names beginning with a dot. Remember that output is a view, not proof that every path is safe to change. Use cd followed by a directory path to change location. Tab completion can finish unambiguous names or show choices. After a large move, run pwd and ls again. That small verification habit prevents many destructive mistakes. mkdir creates directories. mkdir-p can create missing parent directories. Touch creates an empty file when it does not exist, or updates timestamps when it does. Practice in a new lab directory so existing data stays untouched. File estimates a file's type from its content. Stat shows detailed metadata. wc can count lines, words, or bytes. These commands help you understand an object before choosing a viewer or transformation. Cat writes file content to standard output. Head shows the beginning, commonly 10 lines by default. Cat is convenient for small files, but dumping a huge or binary file into the terminal creates noise and may display control characters. Less provides a scrollable viewer and supports searching without loading everything onto the screen at once. Tail shows the end of a file. -n selects a line count. Use Q to leave less. CP creates a copy. MV renames or relocates an entry. If the destination is a directory, the source may be placed inside it. Use descriptive paths and inspect the destination before moving important evidence. RM removes directory entries and usually bypasses a desktop recycle bin. Never copy a recursive removal command you do not understand. Check PWD, list the exact target, avoid broad wildcards, and practice only with disposable lab data. Find searches a directory tree. A safe beginner pattern is find followed by a starting directory, -type F, and -name with a quoted pattern. First, print matches. Add actions only after reviewing the exact result set. Grep searches text for matching lines. Add -I for case-insensitive matching or -n for line numbers. Quote patterns containing spaces or shell characters. Grep finds text. It does not prove what an event means. Most command line programs use 3 standard streams: standard input, standard output, and standard error. Understanding those channels explains why commands can be connected, redirected, logged, and debugged without changing the program itself. A pipeline connects the standard output of one command to the standard input of the next. For example, a command can produce text and grep can filter it. Each stage should do one understandable job. A single greater than redirects standard output and normally replaces the destination file. Double greater than appends. Standard error is a separate stream. Inspect the destination path first, because an innocent-looking redirect can overwrite valuable data. The shell expands wildcards before the program runs. A star can match many names, and unquoted spaces split arguments. Use quotes for literal strings and preview matches with a non-destructive command before copying, moving, or deleting. Linux file permissions distinguish the owner, members of the files group, and everyone else. Read, write, and execute mean different things for files and directories. Directory execute means the ability to traverse or search it. In a long listing, the first character indicates file type, followed by owner, group, and other permission triplets. Read the triplets left to right. Do not treat permissions as a mysterious 3-digit number. Chmod changes access permissions when you own the file or have appropriate privilege. Symbolic modes are readable. U plus X adds execute for the owner. Go -W removes write for group and others. Inspect before and after. Chmod 777 grants read, write, and execute to owner, group, and others. It is not a universal fix. Set the narrowest access that supports the task, correct ownership when appropriate, and understand directory permissions separately. Sudo can run a command with elevated authority according to policy. It does not make a risky command safe. Reread the full command, verify paths and options, and do not use sudo merely to bypass an error you have not understood. A process is a running program with an identifier, owner, state, and resources. PS shows a snapshot, top provides a changing view. Before stopping anything, identify the process, parent relationship, owner, and operational purpose. IP address shows interface addresses and state. IP route shows routing decisions, including the default path. These are local inspection commands. They explain how your lab system connects before you troubleshoot or capture traffic. SS-TULN lists listening TCP and UDP sockets using numeric addresses and ports. A listening socket is not automatically a vulnerability, but it expands what may accept connections. Map it to an expected service and scope. On Kali, sudo apt update refreshes package metadata. It does not install upgrades. Kali recommends apt full upgrade for the rolling distribution, but review the proposed removals and avoid updating in the middle of an engagement when tool stability matters. Now combine the pieces in a fictional Northstar Lab. We have a synthetic authentication log in our home directory. The goal is to preserve a copy, find failed events, create a small summary, and protect the output. First run whoami, pwd, and ls-la. We confirm the account, verify that we are inside the intended lab directory, and inspect names and permissions. No destructive command comes before this context check. Create evidence and output directories with mkdir-p. Clear structure matters. Originals stay separate, analysis works from a copy, and generated summaries have a known destination. This reduces accidental modification and reporting confusion. Copy the synthetic log into the evidence directory. Use stat to inspect metadata and SHA-256, sum to record a content digest. A digest can help detect later changes. It does not prove who created the file or that its contents are truthful. Use grep-in with the quoted word failed and the working copy. Pipe the matching lines into less for review. We see line numbers and matches without changing the evidence file, then leave the viewer with Q. After reviewing the pattern, redirect the filtered lines into a new summary file. Use wc-l to count results, then cat only because the summary is small. If rerunning, remember that single greater than replaces the file. Use a symbolic chmod mode to give only the owner read and write access to the summary. Record the source path, command logic, time, limitations, and result in notes. Avoid storing passwords, tokens, or unnecessary personal data. Before running a copied command, explain the target, privilege, input, output, side effects, and recovery plan. If you cannot, stop. A command that worked in someone else's tutorial may be wrong for your version or environment. Many accidents begin with the wrong working directory. Relative paths and wildcards inherit that context. Use PWD, list the target, and prefer explicit paths when the consequence matters. Familiar prompts are not a substitute for verification. Modern Kali uses a non-root user policy by default. Work as a regular user and elevate a specific command only when required. A root shell makes every typo and untrusted script more consequential. Kali maintains a small trusted repository set and warns against adding random Debian, Ubuntu, Launchpad, or PPA sources. Mixed repositories can create dependency and security problems. Follow current Kali documentation for packages and sources. A grep match, open port, process name, or hash is an observation. Validate context, correlate other evidence, consider benign explanations, and document uncertainty. Ethical hacking requires careful interpretation, not dramatic screenshots. For general Linux fundamentals, a mainstream distribution may be easier. For Kali learning, an official VM offers isolation and snapshots. WSL and containers are convenient but differ from a full system. Bare metal matters mainly when hardware access requires it. Practice by creating disposable directories, navigating with absolute and relative paths, inspecting text, connecting commands with a pipe, redirecting output, and applying narrow permissions. Explain every step aloud, then remove only the lab you deliberately created. The terminal is a precise interface to the operating system. Confirm identity and location, understand paths and streams, inspect before changing, use least privilege, protect evidence, and keep every security action inside explicit authorization. Then Kali becomes a toolkit you can operate responsibly. Read the full CipherVibe guide for the command table, Northstar Lab workflow, safety checks, and current sources. Build the Linux foundation first, practice in an isolated environment, and make every command an informed decision.